All right, so for 5-4, this section is where you can use your calculator. Guys, I need you to listen or be quiet so others can listen. When you are describing the transformations, okay, there is one that I'm worried that you'll forget. So usually people know right away if it's x plus 4, that is going to be a horizontal translation. Make sure that you tell me if it's horizontal or vertical. 4 units, and then Cam, where is it going? Horizontal translation, 4 units where?
Left because it's positive.
Yes. Okay, so it's like the minus the negative, okay, which turns into a positive. That's why it's 4 units left. But you have to think of this. Now, we're going from a 1 as the numerator to the 2, which is like 2 times 1 over x plus 4. Okay, so that 2 means that you have a vertical stretch by a factor of 2. So you should have these two things. Vertical stretch by a factor of 2. So those are the two transformations, okay? Your vertical asymptote you find by setting the denominator equal to 0 and then solving for x. So if x plus 4 equals 0, that means x equals negative 4. With your asymptotes, you need to have x equals, or I will take points off. Okay, Alyssa, why would I take points off if it doesn't say x equals, if it just says negative 4? Okay, so one thing is, it would, if you have negative 4, that is a way that we would say a 0, not a vertical asymptote, because what is a vertical asymptote? A line. So we have to have an equation of the line. Okay, all asymptotes are lines, and that's why they need an equation. Also, you have vertical asymptotes and horizontal asymptotes. If you have a vertical asymptote, you have x equals. If it's horizontal, you have y equals. Now, to find the horizontal asymptotes, you compare the degrees. So the degree of the top, if it's just a constant, what's the degree of the top? 0. Okay, so compare the degrees. Okay, if this is 0 and this is 1, the degree of the numerator is less than the degree of the denominator, which means that your horizontal asymptote, GG, what's that going to be? What was your horizontal asymptote for this?
X or y equals 0.
Y equals 0. Good. Okay, so one other thing you're going to have to do is be able to explain the horizontal asymptote rules. So the main thing there is make sure when you are doing your explanation, you talk about how it's the degrees. It's not the numerator that's less than the denominator. It's the degree of the numerator that's less than the denominator. Your domain and range are going to have to be written in set builder notation. Your domain always will exclude your vertical asymptote. So it should be all values of x such that x cannot be negative 4. The range in most cases, and in the cases that we've studied this year, is going to include all your values except for the value of the horizontal asymptote. Okay, and then you are going to need to put your asymptotes on your graph. So for the graph of 2 over x plus 4, you have x equals negative 4. Remember, when you put the asymptote on the graph, it has to be what type of line? A dashed line. Okay, so don't put a solid line. The solid line is for the graph itself. And then this is going to be y equals 0. Okay, now this is the calculator portion. So you can use your calculator to help you graph this. You're going to need to do a table that has 6 points in it. Now when you're graphing this on your calculator, if you have x plus 4 on the bottom, you are going to have to put that in parentheses, or else your calculator automatically does order of operations and they'll do 2 over x plus 4. Okay, so if you didn't put your parentheses in, the calculator would graph this 2 over x plus 4, okay, which is not 2 over x plus 4. So that's what we need, okay? You can graph it to get a sense of where the picture is, but remember, we just talked about how it's going to be moved 4 units to the left. You can also use your table feature. Sometimes what I do is I change my table set and make it go by half so I can see what's happening in between there. So if you start with your change in table of 1, okay, at 0 you have a half, so here's 1, this is a half here. Okay, at -2 you're at 1, just be careful because this went by 2's. And then I'm going to want to see what happens in between those two. So at -3 I'm at 2. Okay, if you want to see what happened in between those, you could just go to your table set, go by halves. Okay, and at -3.5 I'm at 4. That's just going to help me create a better line. This graph is just going to follow right along your asymptotes here. So that's your first branch. Okay, and then we're going to create our second branch. So I can see it needs to be past -4. So -4.5. Here's 5, so -4.5 I'd estimate to be about right here. -5 is at -2. -6 is at -1. And then these are just getting smaller and smaller. -8 is at -1/2. So again, this is going to be following your asymptote. Okay, you don't want it to cross them. All right, for number 2, identify the asymptotes, the domain, and the range of the function. So for the vertical, you're going to have x equals 3, x minus 3 equals 0, and then you solve. Now this is in a different form. Your horizontal asymptote is going to be y equals 5 because this is a vertical shift 5 units up. So that doesn't necessarily make you utilize the rules. Again, another way you could do that is you can graph it. And if you graph this, the horizontal asymptotes are going to be where the numbers approach. So you'd have to do 1 divided by, in parentheses, x minus 3, and then add 5. And then you can see here, this is going to be up to 5. This is going to be over 1, 2, 3. Okay, so those should match. If you wanted to use the strategies that we did before, you can do that. It's just you have to combine these. To combine those, what would I need? I need a common denominator. Okay, so then I'd have to multiply this by x minus 3 over itself, which would be 1 plus 5x minus 15 over x minus 3. So 5x minus 14 over x minus 3. So let's use our rules now. Okay, the degrees are what? 1 and 1. So if the degrees are equal, how do you find the asymptote? You take the leading coefficients and divide. So the leading coefficient here is 1. So it's y equals 5 over 1 or y equals 5. Okay, it's just when it's in this format, you can pick it out right away. So you don't have to do all that extra work. Okay, and then your domain is going to be all values of x such that x cannot be 3. Your directions will say to write this in set builder notation, so make sure you know how to write that properly in set builder notation. And then for 3, you're going to have the vertical asymptote is x equals -8. Again, you set the denominator equal to 0 to solve. For the vertical asymptote, the horizontal asymptote is going to be y equals -1. Your domain is going to be x such that x cannot be the vertical asymptote, and your range is going to be y such that y cannot be the horizontal asymptote. Yes, Cameron.
So do we have to write the vertical and horizontal? Can we do like asymptotes? Like I did like 3, 1 for asymptote for the vertical, and horizontal I did
Well, it won't be 3 and 1. I would take off if you didn't write like x equals and y equals.
Yeah.
Right? There'll be like a blank that says vertical asymptote, and you'll have to put it in there. And then horizontal asymptote, and then you have to put it in there. So you won't have to say the horizontal, vertical, you just have to put them in the correct spot. For your zeros, remember that zeros you're going to set equal to the numerator. Okay, so the numerator is going to equal 0, and then you're going to solve. So for this one, you had to factor. So two values that multiply to -5 but add to +4 are +5 and -1. When you set those equal to 0, x plus 5 equals 0, x minus 1 equals 0. You're going to subtract. And then I want you to write your zeros as a coordinate point. So your zeros are -5, 0, and 1, 0. Okay, and then if you want, you can automatically put those on your graph. -5, 0, and 1, 0. Okay, your vertical asymptote is going to be x equals -1. That's where you set the denominator equal to 0 and solve. Okay, so if I put that on my graph at -1, okay, x equals -1 here, and then the horizontal asymptote, you're going to compare degrees. Okay, so the degree of the numerator is greater than the degree of the denominator, which means that there is no horizontal asymptote here. All right, now for your graph, again, this is something you can use with your graphing calculator. So you would need to put in there your parentheses, x squared plus 4x minus 5 divided by x plus 1. And then you can see you kind of have like these baseball seams here. I'm going to go to my table. I'm going to go back to ones for now. And then I'm going to find some different points on each side. Okay, so on this side, -9, I'm at -5. At -3, I'm at 4. At -2, I'm at 9. So I can curve this up, curve this over. Just gonna make that more seamless. All right, and then on this side, at 0, I'm at -5. 1, I'm at 0. I already graphed that. At 3, I'm at 4. At 7, I'm at 9. Okay, so again, I'm just going to connect those with a curve. All right, so the domain is still going to be x such that x cannot be -1. My range, I don't have a horizontal asymptote, and I can see that this is going on forever. So then I would want to say all real numbers, but in set builder notation. Do you guys remember how to say that? Y such that?
Y is an element.
Yep, good. Y is an element in the set of real numbers. Good. Okay, so again, make sure you know how to say that in set builder notation. And then that was your domain and your range. I'm going to show you the answer to the last one as well. Okay, so you had to tell me what the asymptote of the function represented and what they were. So in this case, your asymptote is y equals 250 because the degrees are the same. So 250 over 1, y equals 250. Okay, if you set the denominator equal to 0, it would be x equals 0. And in this case, it would represent 250 is the average number of people a day. Those are the daily visitors. And then to the nearest integer, you had to figure out how many would be expected on day 30. So you're going to substitute in 30 for your value of x. And then you should get about 283. Okay, for the first page.